way. Ha! Hey, so we're here again. Today we're going to be doing hypothesis testing example number 3. I want to do plenty of these because hypothesis testing usually takes a while for people to understand. So the more examples we do, the better. Alright, so let's say you work in a store and you have a population average amount of sales for every week in that particular store. Let's say your sales are $12,500 per week. Small store. Let's say you decided to increase the amount of marketing because you think the increasing the amount of marketing can bring you more sales. So you try to increase the amount of marketing to increase your sales. Now, a question you may ask yourself is it working? So you decided to take a sample of 15 weeks of sales after you increase the amount of marketing, and it gave you an X bar of 13,000, which is higher than 12.5. Encouraging, correct? All right? And it gave us a standard deviation of 1,500. So, question that we have as a manager, has there been a change in the amount of sales per week? You know, can we say that that is true? So let's do it. All right, step number 1. We need to set up our HL and our H1. Now in this case, because the question is, has there been a change? Then we're going to say mu equals 12,500, or mu does not equal 12,500. Because the question is asking, has there been a change? And a change could be higher or it could be lower. So we need to create a two-tailed test. Again, if the question says, has there been an increase, then we're going to put a tail on the increase side. If the question says, has there been a decrease, then we're going to put a tail on the low side of the probability bar. Alright, so for question number 2, for step number 2, we need to select our alpha, or our level of significance. So let's do alpha 0.05. Alright, step number 3. Oh, also, remember that for the purpose of a test, the alpha has to be given to you because you want everybody to conduct the same test. And if you pick a different alpha, you may get a different result. So on every exam, they normally give you the alpha. You don't have to come up with it. Alright, now step number 3. We need to figure out which test we're going to be conducting. Now in this case, we're going to assume normality. Because remember, I've only been teaching you normality so far. So we're going to assume it's normal, but notice that we are not given the population standard deviation. So we don't know sigma. Now if we don't know sigma, then we're going to have to use the t distribution instead. And the t test is x bar minus mu. Wow, that's a really bad looking mu. So x bar minus mu divided by s, all of that divided by square root of n. Alright, again, in this particular test, because it's t, we're going to be using degrees of freedom of n minus 1. Now the degrees of freedom, by the way, depend on the different procedure that you're using. So in this particular procedure, it says to use degrees of freedom of n minus 1. Alright, now for step number 4, we're going to set up our graph. We're setting up a two-tailed test. So we're going to have a tail on the right, and we're going to have a tail on the left. And we need to find some critical values to write in there. Now a critical value is going to tell us whether we're going to accept or reject our null hypothesis. Alright, now in this case we're going to be using alpha 0.05. So we got to do alpha over 2 on the outside. So we got to do 0.05 divided by 2. Or alpha over 2. And then we're going to do the rest of that, which is another 0.95 in the center. Okay? Alright, now the way we're going to find this critical value is by using that 0.05. So we need to go to a different table here compared to the previous one that we were using. In this case, we need to go to the one that says student T distribution, okay? The T distribution. Because in this case, we don't know our population standard deviation. All right, now if you go to the T, you're gonna notice that it says level of significance 1 tail or level of significance 2 tail. So in this case, we need to use level of significance 2 tail. 2 tail. All right, so level of significance 2 tail. And we're going to go to degrees of freedom n minus 1. Notice that on this side of the table, we have degrees of freedom. We don't have sample size. We have degrees of freedom. So if our sample size is 15 weeks, then we got to do n minus 1 or 14. So our degrees of freedom is n minus 1, which is 15 minus 1 or 14. So I'm going to go to level of significance 2-tail test, 0.05, and then down to 14. So the number that I'm looking at here, 2.145, it's going to be negative 2.145 and positive 2.145. Those are my critical values. All right, now once I have my critical value, I was double checking my critical value because I was thinking, is that the real critical value? Yes, it is. All right, so now that I have my critical values, we go ahead and conduct our test. So we got to do T equals X bar is 13,000. We're going to subtract 12,500, divide by S 1500, and that divided by square root of n, and n is 15. Okay? So we got to run that baby by my trusty calculator. And I got 1.29. Alright, so my T is 1.29. Center is 0. Notice that this 1.29 that we got, this number here, is inside this area because it's between 0 and 2.145. So it's right around here, 1.29. Now because it lands inside, we're going to say that we do not reject HO for step number 5. Do not reject HO. Now what does it mean when you say do not reject HO? Well, let's go back to the question. Has there been a change in the amount of sales per week? Unfortunately, the answer is no. If we do not reject HO, then what we're basically saying is that we are accepting that mu equals 12,500, and this number that we got for the 15 weeks is not significantly different than what we had before. So we cannot accept that the sales are higher now. Therefore, we do not reject HO, and we're going to have to tell our manager that no, the amount of marketing that we did not create a change in the amount of sales. Alright, well, I hope you understand example number 3 of hypothesis testing. Have a good one.